Where everyone demands your trust, we prefer to give you ours. Aryabhatta Learning Forum Private Limited.
Today we will discuss about a conundrum. Now, how to apply your torque due to pseudoforce to get a right answer. You see, when you apply torque, you apply torque equal to, as you know very well, torque equal to force into distance of the force from the axis of rotation. Force into distance of the force from the axis of rotation. So, when you apply anywhere, suppose your rod is hanging from this point O, you are applying here a force F, and if the length of the rod is L, then the torque equal to F L cross FL sin theta equal to your 90 sin theta equal to 90 degree, therefore sin theta equal to 1. So, FL equal to torque about this axis, torque about O equal to FL, and the force is at right angle to this rod, therefore FL sin 90 equal to torque is to be found out from this. So, therefore, the moment of inertia about this axis I m L square by 3 into alpha. So, alpha equal to 3FL by m, 3F by ml, right. So, 3F by ml is your torque about angular acceleration about this axis. Okay. Now, this axis is fixed. Suppose there is a rod here and you are applying torque, you are applying a force about this, and this rod is lying on a smooth horizontal surface and length is L, mass is m. Now, you are applying a torque about this axis, force at this point, say about A and about B. About A you are applying. So, you have to find torque about this. Now, if you apply the same thing that you had applied earlier, you are finding torque about this, you are finding torque about this. So, F at L you are getting. Now, you have to find the torque about this axis. So, when you apply torque about this axis, if you apply the same thing that you had applied earlier, what you will get? You will get torque 0, angular acceleration 0. But you know, this rod is rotating. So, if the rod is rotating, then angular acceleration cannot be 0. Angular acceleration cannot be 0. So, you have to think about what is the mistake that we are committing here. This is the conundrum here. So, what you have to do is, now you have to, earlier when you were solving the problems of conservation of momentum, you are considering the momenta from the frame of reference, and frame of reference usually we are taking as the system is on the frame, whichever frame it is. Now, here also we have to consider the axis. There, when you are applying, if the frame was accelerating, you are applying a pseudo force. Here, when you are applying, you have to consider the torque due to pseudo force, and there you are applying, there you are taking the frame on which the system was. Now, you have to consider everything here from the axis. If the axis itself is accelerating, then you have to consider a torque due to a pseudo force that will act at the center of mass. Now, here when you are applying here, if the rod is at rest and you are applying, you are getting torque about this, taking torque about this, so torque will be tau equal to F into L by 2. And moment of inertia about this axis equal to ml square by 12 into alpha. Then alpha here is 6F by ml. Then let us come to this point. At what acceleration is this accelerating? Then you will have to take the torque due to pseudo force. So when you are when you are finding the acceleration of this point, acceleration of any point is equal to ACM plus alpha cross R ACM plus alpha cross R, and you know very well, wherever the force is applied in an extended body, wherever you are applying force on an extended body, the center of mass acceleration will be same, F by m. The acceleration of center of mass here will be same as the force here applied here, anywhere. So now what we get? A equal to F by m plus alpha. What is the direction of alpha? You will use your right hand thumb rule. By right hand thumb rule, acceleration, direction of angular acceleration here is right out of the plane of the paper. Angular acceleration about the center of mass out of the plane of paper, and therefore here this is your alpha, and this is your r. This is your alpha, and this is your r. So r direction is downwards. And alpha is out of the plane of paper. So what do you get? Alpha cross r. Alpha is this way. Alpha cross r, you have to get alpha cross r, then it will be like rightwards. So alpha cross r is alpha, you have already got it, 6F by ml into r is L by 2 and angle is 90 degree. So this comes as F by m, so 3F by m, so 4F by m you are getting. This is 4F by m. Then the acceleration of center of mass AMA is equal to 4F. So this point, as you know very well, if the frame is accelerating in a particular direction, then the pseudo force direction will be opposite to that, and magnitude of pseudo force will be mass into acceleration of center of mass, right? So now you have the pseudo force will act at the center of mass backwards, and that equal to 4F. So now you find the torque about this point. Torque due to F, torque due to F equal to 0. So this is L by 2 into F. So here, now instead of about this, it was L by 2F into F, and about this, F into 0 into F. About this, for this force, torque about this is 0. Now torque due to this force about this, torque due to the 4F about A will be how much? How much it will be? It will be 4F into L by 2. This is 4F by 4F, 4F into 4F by L, 4F by L, 4F into L by 2. So 4F into L by 2 here and here. So what happened? Now MA is 4F. MA is 4F. MA is 4F by M into M. So now you have applied torque. The torque is this torque is, now what is the direction of this torque? This torque direction is R cross F. R is this way, F is this way, R cross F is out of the plane of the paper. So 4F into L by 2, this torque equal to 4F into L by 2, that is 2F. Right. So 2F by 2F into L. We know the moment of inertia of this rod about A will be I equal to m L square by 3. Now we have 2FL is equal to I alpha dash. So alpha dash equal to 2FL by I m L square by 3, that is 6F by ml. Now you got this 6F by ml here, and here here again you got 6F by ml. Earlier had also we had got 6F by ml. So you know when this axis is fixed, you got 3F by ml. When the rod is free, you got moment of inertia, the moment of inertia about this axis to be 12F by ml about this axis, and 3F by ml about this axis, and angular acceleration about this axis and angular acceleration about this axis, both are same. And torque, when you apply torque, when you apply force here, torque about this axis due to this force may be 0, but torque due to the pseudo force that acts at the center will not be 0. So to make both the cases in consonance with each other or equal to each other. So this is the conundrum, that you apply force here and torque appears to be 0, but exactly it is not 0. Thank you.
We got you loud and clear. The 2026 admissions are officially open. Tap the link in our bio to learn more. Aryabhatta Learning Forum Pvt.Ltd.